Welcome to our series of videos on how to use HRMAn. In this case, on how to use the new version of HRMAn, namely HRMAn 2.0. For the purpose of this tutorial, I'm just gonna use 3 example images that I have here in my folder, organized in a channel-wise fashion, meaning that I first have channel 1, 2, 3, and I would then have different fields or wells of a multi-well plate. The images that we're going to be running are, as I said, from 3 channels. So we have the nuclei stained with a DNA dye, we have the cells infected with fluorescent Toxoplasma gondii, and in the 3rd channel we have the cells stained with ubiquitin. To run HRMAn, you need to first open KNIME Analytics platform. Once you do this, you're usually greeted with a screen like this, which you can close and then load the workflow by selecting it here in the KNIME Explorer. This is the new layout, so you can see the whole analysis has been streamlined a bit into different steps with instructions for the user, which should make it easier to use. The first step in the analysis is to select the file upload node here and tell the program where to find the images. To do that, we just double click on this file upload, then use this browse button to select our input folder that holds the images, which in our case is this folder. Select with choose and then click OK. This other node down here can be used if you wanted to upload information on the parameters of the analysis in bulk using an Excel template. That can also be found on the homepage HRMAn.org. So if you just navigate to this address, HRMAn.org, you can download it from the download section. There you can also find some more information on how to set up HRMAn 2.0. And we've made, depending on your computer, hardware, and the operating system you're using, we have made several guides that can guide you through the installation and the setup so that everything runs seamlessly. Now back to the analysis. Now that we've configured this, we can right-click on it and select execute, or we can select the node and click on this little execute sign up here in the KNIME menu bar. And once execution has finished, we'll see that this little traffic light jumps from yellow to green, meaning that it has finished. Once this has finished, we'll select the next node, in this case this one, right-click on it and execute it. And then HRMAn will start working. You can also see that something's happening based on the fact that there's this green sign here and that there's messages appearing down here in the KNIME console, which I have minimized for the purposes of this video. Now, once HRMAn is running, in the beginning it's going to ask you a couple of things and it's going to welcome you with this message reminding you that you should have the exact same amount of fields per sample or per well of your plate, just so that the numbers in the end are comparable. And that they should be in the following order within your folder. If that's the case, you can click OK and then decide how to upload your parameters. So for this tutorial, we're going to manually input the information. First thing it wants to know is the magnification they used for imaging, which in this case was 60x, so we just write a 60 and we do not write the x. Next, the program is trying to detect the pixel size from the scale of the images. I have deleted that information from the metadata of these images to show you here that if nothing's detected, it just defaults to 1 micrometer per pixel, and we can input and overwrite this information by just writing 0.15, which is the scale for the images that we loaded. Next, we need to choose our pathogen type from this list, and as I showed you in the beginning, it's images with Toxoplasma. And then we need to choose which analysis type we want to run, and we're just going to run a simple infection analysis that provides us with basic information on the numbers and of the cells, the pathogens, and their replication. It's going to ask us if this all is correct, and if this is the case, we can confirm this with yes. Since for the infection analysis we only need 3 channels, namely the nuclei, the pathogen, and the cells, we have set the number to 3, and then we need to tell the program in which order these channels are. As you can see, channel 0 is the nuclei, channel 1 is the pathogen, channel 3 is the cells. So we'll go back here and say nuclei, pathogen, cells. If this is correct, click OK. It's going to ask you if that's correct. That's the case. It will ask you for the number of Z slices if you wanted to do a 3D analysis. In this case, we just have a single slice per field. And then it will ask you which segmentations to use. For this analysis, we're going to use the classic segmentation of the nuclei as well as for the cells, since I'm running it on my laptop and I don't have a GPU, thus using the more advanced instance segmentation algorithms based on neural networks would take forever. Now, the next thing we can input is our assay design or the assay layout. So in this case, it's an image from a 96 well plate. And here you could input your assay layout. So for instance, if you had replicates of different conditions in the columns and then different condition in the rows and then different conditions in the columns, we could say sample group 1 is in these 3, sample group 2 is in these 3, meaning that they're identical treatments and technical replicates on the same plate. And this would then be used by HRMAn to later on group the data together and do the statistics. But since we only have a single field of view, I'm just going to define that these images are from well B2, which in this case is arbitrary, since it doesn't matter. Then it's going to ask you if this well that you have defined before is infected, and if this was a control, which is uninfected, we would change this to a 0, and the program would not try to look for pathogens in these wells then. However, since they are infected, I'll change this back to a 1. And then it's going to give you this more classic list of overview of wells and the parameters that we've added, and everything is good, so we'll confirm this with yes. And then HRMAn's going to go to work, and the first thing it's going to do is to tell you that it's chosen the model for the replication prediction, which in this case is a model for toxoplasma replication in 2D images. And we're okay with this, so I can confirm this. And then we wait while HRMAn is loading the images, doing the illumination correction and focus detection. Now that this part is finished, you can see there is a little tick mark here, and then we can continue to the next step, which is inspecting the images. So for this, we just select this image viewer, right-click and execute the node. Now that this is done, we can look at our images by again right-clicking on this node and then selecting View Image Viewer. And there you can see our images as they have been loaded into the program, either the pathogens, nuclei, and the cells. And if you wanted to take a closer look at them, you can also click into the images, which will give you a larger preview in which you can change the scale, move around, and you can also use these arrows down here to navigate the underlying data table. So to click left and right, it would change the channel, now to the nuclei, and now to the cells, and up and down we could, if there were more fields, then jump to the next field of view. Now that we're happy with how the images look like and how they've been loaded into program and assigned to the channels, we can start the segmentation by first performing the nuclei segmentation. So again, select the node, right-click, and execute. When it has finished, we can again right-click on it and use this View Interactive Segmentation view. And now that we have the labelings and the input image, we can click on it and it will give us this preview where it has highlighted the nuclei that it has detected. You can change the transparency of these labels here and randomize their colors, shouldn't you be happy with them. Once the nuclei are segmented, we'll repeat this for the pathogens, and again inspect the segmentation. You can see how they were detected here. And last but not least, for the cells. And again, inspect the input images. And once we're happy with all of this, we can then select the next step, which is do the calculations and write the results. So we'll just select this node, right-click on it, and execute. And when HRMAn has finished the calculations and is about to write the results, it's going to present you with this finished message. Just click OK, and then it's going to continue writing the results into an Excel file, which will then automatically open at the end of the analysis. And here we go. So this file now has several tabs. The first tab is giving you some information on the general parameters of the analysis, since which analysis type was run, which segmentation algorithms, with which pathogen, which nuclei were, which channels were analyzed, the size of the images, the pixel size, an instruction on how to read the results, the assay layout, the confidence in the replication prediction of the pathogen. Here, if we would have run a recruitment analysis, you would also find the confidence in those predictions, and then some hallmark numbers with the number of sample groups, the number of wells, number of fields, overall number of cells and pathogen vacuoles, as well as when the analysis was run. The next tab has the assay layout, which tells you which sample group was located in which well and if that well was infected with your pathogen. And then we'll also append this information on the mean focus class and the mean power log slope of the pixel spectral density of the intensities, which are both measures for how well the images were in focus, and it also gives you like a little translation if all images were in focus or if there was something wrong with that particular well, which would then be interesting to inspect manually after the analysis. Next tab contains the results grouped by the sample group. So it first gives you the name of the sample group, the number of pathogens, vacuoles and cells, the ratio between vacuoles and cells, the pathogen load, which is the ratio between the number of pathogens and cells. Then it's going to give you a lot of information on the average size of the vacuoles, their circularity, perimeter, convexity, extent, diameter, as well as the fluorescence measurements with minimum, maximum, mean, geometric mean, and average fluorescence. This is going to give you the same information, but not on the vacuoles, but for the cells. It's going to tell you the percentage of cells that were infected. So in our example, every single cell was infected. Then it's going to give you information on the replication of the pathogen. So first the percentage of replicating pathogens, and then the distribution. So in our case, 97.5% of all vacuoles contained only a single pathogen, whereas 2.5% of vacuoles contained two pathogens, which means they had replicated. Thus we arrive at 2.5% of replicating pathogens in this case. And then in the further columns, it'll give you the information if we wanted to do recruitment analysis, which is the more sophisticated analysis of HRMAn. It's going to tell you the number of vacuoles again, and then how many of those were classified as recruited or non-recruited in either single channel, dual channel, or both channels. Then it's going to give you information on as well as on the code of these vacuoles if they have been classified as recruited, and in the end also some distance measurements. So for instance, the average distance of cells within this field of view, or the average distance of vacuoles within cells to see if they like cluster together or if they're more spread out. These overall same results you will also get by well and by field, and the last two tabs then have information on every single cell, and every single vacuole. For instance, here, all the vacuoles have their unique identifier, which is combined of like the field that they're from and the number of the vacuole. Here it also tells you where, in which field or which well to find this vacuole, where it was located, its size, the geometric measurements, the fluorescence measurements, and the number of contained pathogens and whether it's replicating. Should you do the recruitment analysis, then some further columns here would also have information on whether this vacuole has been recruited with either single stain or 2 proteins if it was from dual channel. That's the new results file. Then the last thing that you can also do is to have a quick inspection of your data using this data dashboard. So this is an optional step in the end. So you can just execute this. And then once again, once the execution is finished, you can inspect the data if you just right click on it and select Interactive View Data Dashboard. It should open a new window, and then you can see a quick number of graphs for each well, your cell number, vacuole number, pathogen number, the size distribution, the ratio between vacuoles and cells, the pathogen loads, infection levels, and so on. Obviously, with just a single field of view, this is rather boring right now, but with many conditions, this can be a quick way to interact with your data. And the last thing to show is that what has happened in the background. So KNIME has also cleaned up your input folder by compressing all of the input images into this archive file that can be used for long-term storage. And this folder also holds the Excel results file that we had looked at before. And with this, thank you for using HRMAn, and good luck with your experiments. And remember, all the information can be found on our homepage, HRMAn.org.